Okay, so for the topic today, it's actually a couple of topics, but they're related. We're looking at graphing functions with restricted domains and using parameters. This is leading towards sections 10.6 and 10.7 in the parent class, where we talk about parametric equations. It's a fairly big topic in Calculus 2 and Calculus 3. And so this is hopefully going to help prepare you for what we're going to do in the parent class in those sections. To start with, I want to look at what it means to graph a function with a restricted domain. This is actually very straightforward. Suppose I wanted to graph the following: y equals 1/2 x minus 1, but then I add this little condition. I say x is between -2 and 1, something like this. Essentially what this means is I want to graph this. If you notice, this is the equation for a line. It's in slope-intercept form, but I'm not going to graph the entire line. I'm only going to graph the parts of the line where x is between -2 and +1. So I know how to graph a line in slope-intercept form. -1 would be the y-intercept, and then my slope is 1/2, meaning I go up 1, my rise is 1, my run is 2. So go 1, 2, like that. So starting from -1 right here, I would go up 1 over 2, and I would get a point right there. Okay, normally I would just put a point straight through, or sorry, a line straight through these 2 points with little arrows on the end to indicate that they go forever in either direction, and just call it done at that point. However, like we said, we don't want to graph everything. In fact, this point is too far for the graph that we want, because x, our x coordinate for any point on this line that we're going to graph, has to be less than or equal to 1. So that means we're only going to go about this far. Okay. Now, I do need to go towards the left as well. So if my slope is 1/2 going to the left, I can go down 1 and over 2. So that's going to go like this. Okay, so graphing my line, I'm not going to use all those points. I'm only going to use these 2, or these 3 rather. Notice that the x coordinates of the points on this line are all between -2 and +1, which that restriction is requiring us to do. So that's the basic idea of graphing with a restricted domain. It's something that we do a lot of, like I said, in Calculus 2, Calculus 3. And there's not really much more to this. So on the handout today, you're going to be doing several different graphs where the domain is restricted. You're going to see graphs of linear functions like this. You're also going to see graphs of parabolas and exponential functions. If it's been a while since you've graphed those types of functions in algebra, you can do it the old-fashioned method of creating a table of x and y values, plugging in values for x, getting corresponding values for y, and then plotting those points and putting a graph through the points. If you do that, just remember that the restriction is telling you what values of x you're allowed to use. So if I wanted to use an xy table to plot some points here and graph this line, I couldn't pick -3 for x, for example, because that's not in this range right here, or in this interval. Okay, but that's the first 8 problems are of that type. Nothing terribly fancy there. The next topic is a little bit more directly related to what we're doing in sections 10.6 and 10.7, which we should be covering those next week. These are, it's a concept called parametrization, or parameters, or parametric equations. Normally when you have a function like what we have here, you have what's called an independent variable and a dependent variable. And the idea is that the independent variable is the thing that you plug inputs into. And then the dependent variable depends, hence the name, on what you plugged in for that independent variable to give you outputs. So there's that independent and dependent sort of relationship between these two. What we do in the case of parametric equations is we take both x and y, and we make both of them dependent on a single third variable that we call a parameter. So here's an example of what I mean. So, and in this section, really, you're just completing some tables. And then in the parent class, we'll look at graphing with these. So you're going to see equations that look like this. X of t equals, let's say, t squared. Y of t equals 3t, something like this. Okay? So what we're doing here is we're creating a table, kind of like an XY table, but it's going to have more columns in it. You're going to have a column for your t's, a column for your x. It'll actually say x of t in the handout, a column for y of t, and then there's going to be a fourth column, which oftentimes you don't really need this fourth column, but I'm going to put it here while we're getting used to this concept. X of t, y of t. It's going to take those two corresponding values and put them into an ordered pair. And then what we're going to do is we're going to pick some values for t, say -1, 0, 1, and 2. On the handout, I'm going to give you the values of t I want you to plug in, and then you fill out the rest of the table. What happens here is this value for t is going to give me a corresponding value for both x and y simultaneously. So if I plug -1 in for x of t, it's going in for t, that becomes -1 squared, which is 1. If I plug -1 in for t here, for my y of t, it becomes 3 times -1, which is -3. These two things go together to create the ordered pair 1, -3. Notice that I didn't plug in an x as an input and then get a y as an output. I plugged a new variable t into both x and y to create an ordered pair. Notice also that the ordered pair doesn't include the value of t. This is what we call the parameter. The parameter just controls the x and y coordinates for any point in this table. So if I can go out and fill the rest of this table out, I would get 0, 0 in this case, giving me the point 0, 0. If I plug a 1 in, I would get a 1 and a 3. So the point 1, 3 would be here. And then I would get, I can plug in a 2, and that would give me 2 squared, which is 4. 3 times 2, which is 6. So that gives me the point 4, 6. Okay? So on the handout, you're going to go through and fill out a few of these tables. And just to give you sort of a preview of what's coming up in the class, there's going to be a process that we talk about called eliminating the parameter. So the idea is that you will be given parametric equations like these. And even though each of these variables, the x and the y, are both determined by the values that we plug in for our parameter, in some cases, you can remove that dependence on t by establishing another relationship between x and y. So at the end of the handout today, there's a question that asks you to go look at the tables that you graph or that you filled out and investigate possible connections between x and y. Does there seem to be some relationship between the x and y values in that table? Hopefully that'll help us prepare for the topic of eliminating the parameter in the parent class when we get there next week. But that's it. It's a relatively short one today, pretty straightforward, just some graphing and filling out tables. So wish you all luck.